Hello everyone, I'm Ravi Kumar Bandaru along with my teammate Pranav Kumar. We are here to present our uh, Dbms programming project on implementing ACID properties using Python. For this, we'll execute a transaction where the depot ID D1 will change its name to DD1 in both stock table and as well as depot table while preserving the ACID properties. To begin with, I'd like to explain that our database in PostgreSQL has three tables: product table, depot table, and as well as stock table. Where product table has its primary key as prod ID, and the depot table as dep ID, and these two are the foreign key constraints referring to each other in stock table as uh, dep ID and product ID. So we will execute a SQL query where we'll change D1 into DD1 while preserving ACID properties. So for this, we'll begin with importing packages, and the required packages here are PSY COPG2, which is used to connect our Python code uh, with the database or PostgreSQL database, and we'll import tablet from tablet. This actually uh, makes use of table forms. Mm, like it will format all our information into a table so that we can write our queries and execute. So we'll begin starting with we'll print beginning so that we could know that the process begin, and we'll first set up a connection to our PostgreSQL database, and for this we'll use psycopg2.connect, and in which we'll give all our attributes of all the values of our host database name, user, password, and our port, uh, which are uh, in our system, and then we'll print our connection. And like our main aim is to write SQL queries maintaining ACID properties. So for this, to maintain atomicity, here we use we'll set auto commit as false. This is because like we know that atomicity ensures that a transaction is treated as a single unit. Uh, so in this, when we set auto commit as false, it treats a whole transaction as a single unit. So uh, like we'll get the basic atomicity property, like it fails if anything fails, if any query fails, the entire transaction fails, or else if everything executes, the entire transaction will be completed. So for this, like we'll be having commit and rollback. When we set this auto commit as false, we'll have commit method and as well as rollback method. We'll use commit method when all the SQL queries are executed successfully, or else if there is any error, we'll use rollback method. And for isolation, we'll set level as 3, because in Python different databases have different isolation levels. So for this, in PostgreSQL database as level 3 for serializable, to maintain isolation that which ensures uh, the intermediate states of a transaction are invisible to other transactions until the transaction is completed. And like and maintaining consistency, to maintain consistency, will while creating database in Python itself, will ensure uh, will define all our database schema properly and enforce constraints, uh, and as well as durability is maintained by using commit function. We'll use this commit function at the end so that any changes made into the database are saved to the database. So we'll begin with try block. In try block, we'll create a cursor object to execute our SQL queries. So the cursor object is created and it is saved in uh, cur variable, and the other part of the program will be explained by my teammate Pranav.
Good evening, everyone. Here, since the attribute debit is a foreign key constraint which is referenced from the table stock to table depot, we will be updating debit first in the table stock, then we'll be moving on to the table depot to maintain the consistency of the transaction. Here in the line number 27, we will be deleting rows in the table stock where the debit ID is equal to D1. And then in the table 32, we'll be deleting rows in the where the repeat ID is equal to D2 in the table depot. And then we'll be inserting new rows into the depot table where the debit ID is DD1, which we will then be updating the repeat ID in the depot table in the from in the row number 44. And we'll be updating the report tables. We will be inserting new DD1 table rows into the stock table where the debit ID is DD1. And when the after the try block of when the above transaction is successful, we will be using the commit function to commit the transaction to the database, which will make the transaction as permanent. We will then be using exception handler to make sure to ensure that if any error occurs, we can use the rollback method to roll back the entire transaction to ensure that it doesn't commit to the database. Finally, we'll be using the finally block to ensure that the connection to the PostgreSQL database is closed. Here, we'll be using commit method to ensure that the durability of the transaction is protected. And we'll be using close function to ensure that the connection to the Postgre database is closed. And then we'll be the entire transaction is finally committed to the database. Thank you.
Thank you, Pranav, for your explanation of executing all the SQL queries. And this is overall Python code which implements the transaction which we have chosen to perform on our PostgreSQL database, and it ensures all the ACID properties. And thank you everyone.
Thank you.